Hi, it's John, and today we're going to the project, which was basically about planetary data visualization. And these are the data that I've imported from the CSV file that I've downloaded. And from here, we're going to create a visualization. I think we have roughly 3,200 and 3,622 records of planetary data, and uh, also about 26 the columns or attributes. And this is a very huge data, and we cannot be able to discuss all aspects or all of the attributes and the records of the data or individual components, but we will basically do some analysis on these and then try and discuss on the few aspects of the data that we wanted to present our story. So my focus is basically on the, the planetary discovery methods, the, the planetary periods or days, uh, the radius with respect to Jupiter radi, and also the number of planets. So there's a few attributes that I'm going to discuss or tell the story with respect to this project. So here's what I've done in my project. So I can't be able to get the visualization complete and to tell the whole story, but this is basically the sort of a visualization that I did, and this is the uh, this text basically answers some of the questions from question 4, and as we can see from the first visualization, we see the state bar chart. We have uh, the y-axis as the number of planetary objects, and we have the x-axis, which consists of here, but that is basically categorized, meaning that we did not present all the years because I can't be able to construct a graph. So what I did is to categorize the here component, which is 1999 and less. 1995 represent 1990 to 1990 to 1995, and the first the label represent 1990 and then the backwards. And then we have 2000, which is basically a range from 1995 to 2000 and so forth there, just like examples here. So this is the graph that it shows the depth, and also we have the staked bar chart, which we have the planetary discovery methods. We have created the legends, which we assigned them as a planetary discovery methods, RV, and G stands for not given, transit, imaging, microlensing, timing. When you look at this, the graph seems sort of not really staked, but there's a little bit issue in there, which we can see from this, that from 2015 to 2020, which represent this the last bar, or if you can see from 2010 to 2015, which is represented by 2015, we can see that the transit detect detection mechanism or is being used to it represents a lot of them, like first stake and then the other one and then so forth. That is because I was trying to create a sort of a drop down button here. There's another category that involved, which I created, and then I was thinking of creating a combo box or drop down button, and then select each of those categories so that the graph can be able to respond to that. Unfortunately, I didn't get that, and then I was unable to reanalyze the data, so I just created the graph just like this. So that is that, and Next shows the planetary reduced range versus discovery method graphs. So here also the legend is still the planetary detection discovery methods is not given, but it's just different color codes. And here we can see that transit discovery method has been used to identify a lot of the planetary objects. So we can see that transit discovery is used to identify more than 2,000 plus for those planetary radius range between 0.1 to 0.5 Jupiter radii. So the new category has been created, and that is planetary radius range. Those planets that have a radius of less than 0.01 Jupiter radius is located there, and then 0.01 to 0.05. There are a few planets has been identified by transit discovery methods, and then we have 0.01 to 0.5 to 0.01. I think when we look at Earth, it falls into within this 0.05 to 0.1. Then we have the radius range, and Jupiter itself falls into this. So not many, the transit discovery method has been used to identify most of the planetary objects thus far. And down below is the graph showing the planetary periods versus discovery methods. Also the periods, there's a number of days they take to make a one full revolution. So we have the range here, another range has been created, the category has been created, and those planets that have less than 0.1 day, and those planets who have falls between 0.1 to 0.5, 0.5 to 0.1, and so forth. These are the ranges. And Earth is basically in here. It falls onto this category where it has 365 days. So we have 100 to 500. It falls into this category. So yeah, this is also transit discovery method is used to create detect a lot of planets with the properties and so forth there. So these are the three different the graphs that I've created. Fortunately, I cannot come up with the graph of visualization, which is more interactive and so forth. These are the graph that I created, and go back to the coding here. This is the coding for this. So the style sheet, and the first few texts there, and the script for the different graphs actually is separated there. This is the script for the first graph, and I think it stops on, let's see here, and then the script for the second visualization, which the data is actually extracted here. It's here. This is the data that we analyzed, will be processed for this the second graph. We have radius range of less than 0.1, etc., and then transit different discovery methods used to identify that. And then we have the adding there, the stacked function there, and that defines the axis, x and y axis, and the text. It creates the G elements, and then yep. So these are basically the code for the second script, and we have the third one here, which also use this data. The data has been analyzed using Excel and then it's imported in here. So from there, it can be able to create a visualization. Right, for the first one, the data is loaded from the CSV file, and I think, yep, this is the data is loaded from here, and going back here, it shows the variable. The variables, the outer width, the inner width, height, and width and height, and also the dimensions, the discovery, and the number of planets has been, the variable has been created for them, and then yeah, so it's basically what so when we run this, we get this visualization. Unfortunately, we cannot create a single interactive visualization due to the timing factor and also other. Okay, thank you.